A Java payment service crashed every 2 hours with out-of-memory error. The heap dump showed thousands of Netty HTTP2 stream objects. The root cause? HTTP2 server push was enabled by default, pushing 50+ resources per request, each creating a stream that was never garbage collected because the client never consumed them. And Netty's default max concurrent streams was integer, max value, allowing unbounded growth. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover HTTP 1.1 vs HTTP 2 versus HTTP 3, QUIC. Imagine a restaurant kitchen. HTTP 1.1 is a single chef cooking one dish at a time. HTTP is a chef with multiple burners. HTTP is a chef with a delivery system that doesn't get stuck in traffic. HTTP 1.1 opens a new TCP connection per request, limited to 6/8 per domain. Head-of-line blocking means a slow response blocks everything behind it. With 100 resources, you get serial queuing. This Node.js server simulates HTTP 1.1 behavior. Each request takes 200 ms. With 6 connections, 100 resources take about 3.4 seconds. HTTP 2 multiplexes multiple streams over a single TCP connection, eliminating app layer head-of-line blocking. But TCP itself still has head-of-line blocking if a packet is lost. This HTTP 2 server handles multiple concurrent requests over one connection. No app layer head-of-line blocking. HTTP 3 runs over QUIC, which uses UDP. Packet loss on one stream doesn't affect others. Connection establishment is faster, and connection migration handles IP changes. QUIC uses a connection ID instead of IP, port. When the client's IP changes, the server identifies the connection by ID and continues without rehandshake. Don't trust generic benchmarks. Test on your infrastructure. For APIs with low packet loss, HTTP is fastest. On lossy networks, HTTP 3 wins. Use curl to benchmark each protocol. Measure total time for 100 requests. Results will vary based on network conditions. This is the same issue we highlighted at the start. Here's exactly why that happened. The server pushed 50+ resources per request, each creating a stream object. Netty's default max concurrent streams was integer, max value, so streams grew unbounded until memory ran out. The fix was to disable server push and cap concurrent streams. The key change was server, HTTP 2, push-enabled equals false, and server, HTTP 2, max concurrent streams equals 100. This prevented unbounded growth and resolved the OOM. Never trust default HTTP 2 settings in production. Always cap concurrent streams and disable server push unless you've measured its benefit. Pushing resources the client already has cached wastes bandwidth. Always check cache or use 103 early hints instead. If your backend opens a new HTTP 1.1 connection per request without pooling, you'll hit OS file descriptor limits. Use keep alive with connection pooling. Many firewalls block UDP. Always implement fallback to TCP. Also, some cloud providers have UDP flow limits. QUIC is still evolving. The current standard is QUIC v1 RFC 9000, but older drafts, e.g., H327, H329, are still in use. Ensure your server and client libraries support the same QUIC version. Most modern libraries, e.g., MSQUIC, Quinn, default to v1, but some CDNs may use draft versions. Always check compatibility documentation. The article mentions ALPN, but doesn't show code. Here's a Node.js example that negotiates HTTP 2 or HTTP 1.1 via ALPN, with a fallback to HTTP 1.1 if HTTP 2 is not supported. QUIC's mandatory encryption, TLS 1.3, increases CPU usage by 10–20% compared to HTTP 2. In production, monitor CPU and consider offloading QUIC termination to a content delivery network or using hardware acceleration. Without proper capacity planning, enabling QUIC can degrade overall server performance. For high latency on mobile, check if HTTP2 is used and enable HTTP3. For memory issues, reduce concurrent streams and disable push. For QUIC failures, test with curl and implement fallback. Let's run through some common interview questions. How does HTTP2 handle HOL blocking? Eliminates app layer HOL but TCP HOL remains. When choose HTTP3 over HTTP2, on lossy networks or for fast connection establishment. What happens on QUIC migration? Connection ID persists, no re-handshake. And a few frequently asked questions. Which is faster on reliable networks? HTTP2 slightly faster due to lower CPU. Difference between HTTP2 and HTTP3? HTTP2 over TCP, HTTP3 over QUIC UDP. How to enable HTTP3 in Nginx? Use listen 443 QUIC and HTTP3 on. HTTP2 is great for most modern apps, but watch for TCP HOL on lossy networks. HTTP3 shines on mobile. Always test with your own traffic and disable server push by default. Ready to go deeper? Up next, WebSockets explained, then long polling versus SSE versus WebSockets, then IP addressing and Anycast. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.